Hello, welcome to section 1.4 Scientific Notation from chapter 1. We use scientific notation, which we have in this form here. 1 times 10 to the whatever power, because we measure things that are really small sometimes, like a human hair, or sometimes things that are really big. And so instead of having like those big long numbers, that take up the whole page, that people would like lose count of how many zeros there were and all that, we use scientific notation because it's a lot easier to look at that and tell, because you have an average of 1 times 10 to the 5th hairs on your scalp, but each one is only 8 times 10 to the minus 6 wide. And so we use these numbers in scientific notation to just kind of help us make it easier to talk about the numbers. So when you write a number in scientific notation, there are 3 basic parts that are important to look at. The first one is the coefficient. Okay, the coefficient is going to be that number that begins the scientific number. Notice that this will always have 1 decimal place, okay, and it'll only have one number to the left of the decimal place. Now, it can have more than that, but it can have more than that to the right of the decimal place, but only 1 number to the left of the decimal place. Okay, that's very important to remember. Also, there will be a power of 10, okay, and so it will be 10 raised to something. So if the power of 10 is 3, it's going to be 10 raised to the 3rd power. And then finally, there's going to be a unit. Okay, and the unit are those units of measure that we talked about in section 3, M, which would stand for meters. So if we have 2,400 meters, the way that we would write that in scientific notation would be 2.4. And then what I've got to do is wherever the decimal would be, I have to go back 1, 2, 3 places. Okay, now I said that power was 10 to the 3rd, but I'm making this is a big number, right? So if it's a big number, this number is going to be positive. So that would be 2.4 times 10 to the 3rd. And a lot of times what I'll do is I'll work them, and then you have additional slides on your handouts that go through the details like the book does. I work them usually just how I work them, and so you know that you can slow this down or speed it up or skip through different sections or go back and replay things. So I don't worry so much about going really slow, because I know you can go back and listen to it over and over again. So this second one down here that they've got 0.00086. So 1, 2, 3, 4. I had to move 4 places that time to get to that 1 number to the left of the decimal. So it becomes 8.6 times 10 to the minus 4, because that's how many times I had to move back. Does that make sense? Hope so. So here's some powers of 10, and the reason it's 10 to the 4th is for 10,000 is because I'm multiplying 10 times 10 is 100, times 10 is 1,000, times 10 is 10,000, and so that 4 means that I have multiplied 10 by itself 4 times. And so that gives me that power. Notice that 1 is 10 to the 0. Anything to the 0, 10 to the 0 is 1, okay? And 10 to the 1, you only multiply 10 by itself. You don't. It's just 1. So 10 times 1 is 10. And then if you multiply 2 10s together, you get 10 squared, or 10 to the second, 3 times 10 to the third. So that's how you get these powers of 10. When the number is smaller than 1, that is, it's a decimal, you do it the same exact way. You're going to move to the right, but since it's a small number, you're going to have a negative exponent, okay? If it's a big number like we had before, it's going to be what? A positive number. So that's really all you have to remember, is that if you're starting out as a big number, it's going to have a positive exponent. If it's a small number when you start out, it's going to have a negative exponent. So the diameter of the chickenpox virus, which also causes shingles, by the way, is 0.000003. I think I got those right. You can see how you might mess up having to remember how many zeros and everything. And so in scientific notation, it helps because all we have to do is go 1, 2, 3, 4, 5, 6, 7. Move that decimal so that 3 is in front. And we moved 7 places. Why is it negative? Because that number was little. It's less than 1. So that exponent has to be negative. So I was telling you earlier, there are some really big numbers in the world, and there are some really small numbers in the world. Usually something like the mass of a human, or about 68 kilograms, that's right there in the middle. You know, that's not so bad about needing to be in scientific notation. But, you know, if you're talking about 550 billion liters, it's also a lot easier to write 5.5 times 10 to the 11 and keep that straight. Or and I'm not even going to try to decide how many zeros that is, I'm just going to say apparently it must be 18 or 20 or whatever. It's a lot easier for me to write 1 times 10 to the minus 19 kilograms than it is for me to write that every time. My hand would get really tired. So when you're doing this on the calculator, I'm not putting a calculator up here because like everybody has a different one. I use a TI-83, but I mean there's all kinds of different calculators, and so you enter, if you want to enter 4 times 10 to the 6, what you do is, like everybody will enter 4. Some calculators will have a key that says EXP. Others will have, like mine has EE. And if you do 4 and then EXP 6, if that's what yours has, or 4 EE 6, then you will get a display that looks kind of weird. It's like 406, or it could be 4 with the 06 as a superscript, or it could even say 4E06, which is what mine does. That means 4 times 10 to the 6. Okay, you just have to remember that. If it's to the minus exponent, you do the same thing, except you do, after your EXP or your EE, there's a key that'll either say plus minus. Mine actually has one that does this, so I can make it a minus if I need to, and then the number, and then you'll get this same kind of readout like we saw before. That is exactly what it's supposed to look like, so don't worry. All right, so let's do some of these. Let's write some of these in scientific notation. All right, so you try to do these, so just pause this and go ahead and see if you can do them, and then come back and I'll work them for you. All right, so this is a big number, so I know I'm going to have a positive exponent, and so if I say 1, 2, 3, 4 places, I'm going to have 6.4 times 10 what did I say? 1, 2, 3, 4, right? So 10 to the 4th. On this one, I'm going to go 1, 2. So 2.1 times 10 to the 2. And on this one, I'm going to go 1, 2. So 1.38 times 10 to the 2. Did I make any mistakes? I hope you caught me. Yes, I did. This one started out as a small number, so that should be a what? Negative 2. All right, so 2.1 times 10 to the minus 2 meters. That's it for section 1.4. You're ready for section 1.5 next.